Welcome back students to the lecture on media computation. In the last class we discussed how to make a negative of an image by inverting or subtracting the color values from 255, and we saw the results. So if we have an image, it will make a resulting image which is just like the image we used to see on the plastic film in the old times. And we discussed that if we take the in negative 2 times, that gives us the positive again, the original image. The next topic we will discuss today, it is how to convert a color image into a grayscale or black and white image. So black and white image, which we normally call, it's basically a grayscale image where the brightness changes only. So for example, so brightness changes in this. So if you see over there, the brightness is basically the light intensity. So in the grayscale or black and white image, the light intensity changes between pure black, which is 0, until pure white, which is 255. So it changes between black and white. So all the shades between the black and white, they are included, they are used to create an image. So a normal grayscale image, calling it black and white is not correct, because pure black and white, two colors, they are not enough for making an image. They will make a very bad image. So a pure normal image that we see, we call it grayscale, and grayscale means that it can have any range of color values that are between 0 and 255. So practically there is only one color used. So there is only one color in this case, and that color value is basically this thing, that all the three colors R, G and B, they have same value. So remember, typical exam question, the grayscale, in the grayscale image, all the three color values are same. Okay, so don't try to write that they are same and equal to 200 or equal to 100. No, you will not give any specific value, because the color that is in the grayscale image, it will depend, but it will be equal all the time. Somewhere it will be 0 0 0, somewhere it will be 10 10 10, 100 100 100, 200 200 200, or maximum also 255 255 255. But for all the three color channels, red, green and blue, they have same color. So remember this thing, we saw it in somewhere in the last chapter, that if the three colors are same, red, green and blue, we practiced it ourselves. If they are same, then you get a gray color. So if the color value is for example high, for example it is 200 for all three of them, so in that case you will get a light gray color, light gray. Okay, remember the color value is high, color is light color. And if the color value is too dark, maybe 100 100 100, then in that case the color that will be created, it will be dark gray. Is it clear? So we are basically having a set of different gray colors inside a grayscale image. So how we convert a color image into a grayscale, that's the discussion over here. So what we need to do is that we need a value that represents the darkness of the color, and that is basically the luminance. So for example, if there is a pixel and it has three color values, for example R is 10, G is 140 and B is 251. Now you have three color values. So if I want to convert this image or this pixel into a grayscale, What I want is that I want some method to represent the darkness of this color. Whatever is the level of darkness of this color, I want to represent it. Or basically you can say I want to represent the luminance or brightness of this color. So what we do is that we convert this color pixel into the value which is the brightness of that pixel, and we get it by doing the average. So what we do is effectively we take the average of these three values. So basically if I have got these three values, I will do is I will take 10 plus 140 and 251. I will just add them up and divide it by 3. So all these three values I take an average, a simple averaging method, and whatever the result comes, that value I will save. That will represent the brightness of that pixel. So the color value, I just ignore it, whatever the color was. So for example, here we are mixing green and blue color mainly. Red is very small, but green and blue color, whatever is the resulting color, now that color is gone, only its brightness will remain over here. That the color that this color has high brightness or low brightness. So in this case I think it will be high brightness because these two values are high. So this is it, what happens. There are lots of ways that we can do this thing, how to find the brightness of the color, but this is the most simple one, where just take the average and use that average. So how it works, this is it. What we do is now again this code over here that you see, there are two ways you can do this coding. This program you can create in two different ways. One way which I like, for example, is get r equal to get red from px. Okay, so they have used different names. I will be using different, and g is get green. Okay, and then b is get blue. Okay, so then what I want to do is I will create an avg variable. Avg equal to r plus g plus b and whole divided by 3. You have to put brackets, be careful. Okay, so this I will do. This will give me the average value of the three colors. Now what I can do is that the next step, this is almost the same step you see over here. They have done it in one line. I am doing it in 4 lines to make it more readable. Here they are using get red. I use over here get red. The only difference is that I have used the variable r and I use this variable r over here, and they are not using any variable r. Then I have got get green and get blue. Okay, so instead of the variables r, g and b, they are using these functions directly inside this line over here. So they divided by 3, and I called this variable avg for average. They give it another name, intensity. And then what they are doing is that with this intensity variable they create a new color. So make color, and for the color, you remember make color will take 3 values. So you give the 3 values which are same. Remember the gray color, it has all 3 values RGB equal. So here they are equal. In the make color, intensity, intensity and intensity, all 3 of them are equal. Is it clear? So we make a new color and then we set this color on the pixel. So this is one method to do this, and the second method is the one that I am doing over here. So you can do it like this also. It's up to you, whichever you prefer. So you used the get red, now I will use set red. Set red px comma avg. Okay, again set green px comma avg, and finally set blue, and same thing. So three things we have over here. So set red, set green, and set blue. I am using them to set the pixel value, and I set the same value AVG. This will effectively do the same thing that is being done on in this line. So effectively, if you see the first three lines, they are for first four lines, you can say they are for this line, first line, and the last three lines they are for this line. And this is the coding style. Only the difference is that they are making it, they have done it in a compact way, and I'm doing it a, in a big, larger code. So up to you. It depends. It does not make difference. So this is it. Now let's go back to the JS, and I will show you over there how it works. So here it is, JS. Let me open some code. So this is some code, make lighter, and so I will modify this code. So I save it as a new code. So this time it's EF, and here let me call it mm, Grayscale. They are using Grayscale. Okay, so this is the function. So inside the function, what I do is that I will call the pixels. I get the three color values RG and B. I can make a new color. It's up to me. So I will make a new color, but for that, first of all, I will take the average. Average equal to R plus G plus B divided by 3. AVG, AVG, AVG. Okay. So three color values, AVG, AVG, AVG. It will give me a new color, and I can use this new color to set it on the image. So this is the program to make Grayscale. It should be not make it convert to Grayscale program. Okay, so it will take an image. So two images are enough. One image is P1 and P2. So what it will happen is that one image is my original and the other one I will modify. So modify, I will do it only one time. So Grayscale. So P2 I will modify, and P1 I don't modify. Here I will be using an image that is more human like face. So the same face I use as in the lab. So what image they use? Same, Barbara.jpg. So let me use the same here. So what is happening over here? I select the image file, I make two images, two image objects, picture objects, and then I pass one of those objects, so P2, I pass it to the function, grayscale function, and inside the grayscale function I call the pixels of this image one by one, and I am just taking the average of the each pixel color value, and then I set it to the pixel. So this is ready. Now save it and load it. So these are the two images that you see over here, original and the grayscale. Clear? So pause the video, make sure you make this code yourself, and try it yourself. Only then you will master it, you will understand when you do it yourself. Another method, instead of making the color, so these two lines of code I can omit and I can use I can use the set functions also. So here it is. So I will be copying the avg and this time I use the three set methods and it will give me the same result. So try it, it will give 100% same result. So go through it, make sure before going next, make sure that every one of you has done it practically. Without doing something practically, you will never learn. It is common when you see the code, it is a common thinking in the mind when I was in this student age, when teacher was saying something, everyone thinks like this, it's so easy, I can do it, I don't need to practice. But when you will start practicing, you will see mistakes, you will see errors. Okay, so this was about converting to grayscale. Another important thing is, now coming back, another important thing related to this, if you remember previously what we did for the negative, when we take a color image, we can convert it to negative, and if you take the negative again, you will make the original image again. You will get back your original image. But the important question is, can we do the same thing with the grayscale? So for example, I have a color image. Okay, so for the color image, I convert into gray scale image, and if I take the grayscale image and try to apply the grayscale function again, will it give me the color image? That's the question. What do you think? So no, the answer is no. When you convert a color image into a grayscale, you are basically losing information. For example, I gave you the example, red is 10, green is 140, and blue is 251. Now when you convert it into an average value, you give it a new value. I don't know, just maybe calculate it. So 150 and make it, let's make it simple. 150, that's 300, 400. So 400 divided by 3 equals to 3, 1 is 3, 3 is 9, and I think it will be 133. So the new value, the average that will come for the three colors, it will be 133 for all the three colors. Okay, so when you converted this color image pixel into a grayscale pixel, now you have permanently changed something. You have permanently changed the old values by these new values. So 10, it is gone, and now the new value of red for this pixel is 133. Now that this has happened, now there is no going back. You cannot convert it back to the original values because that information is now lost. You cannot convert this 133 into 10 and this 133 into 140. So you have lost this information, and with this information you have lost the colors. All the colors are gone. So remember, when you convert a color image to grayscale, you cannot go back. It's a one-way process, not possible to convert back, to get back that lost information. So we no longer know what are the ratios between the red, the green and the blue. Okay, now they are all same. We don't remember the old values. We don't know the ratio between these colors. We no longer know any particular value, so it's not possible to convert a grayscale image into color image. One more thing that happens is that in reality, scientists, they did experimented with the grayscale images, and they tried to find out which one is the best grayscale image. We have just created one grayscale. If you see over there, we tried one grayscale. Scientists try to find out if this is the best grayscale or not, and they did lots of experimentation, and they saw that in reality we don't perceive it like feel these colors in equal amount of brightness or luminance. So we don't feel the red, the green, or the blue colors as in our related to our eyes and our brain. These colors don't have the same impact when they are present inside an image. They don't have the same impact on our systems, on our visual systems. So the Photoshop that we did, the grayscale conversion we did over here, that was okay, but practically it is not so better as compared to some professional software like Photoshop. The grayscale that is produced by the Photoshop, that is very nice, and that is very similar to what we can see with our eyes. And also the grayscale that is generated by the TV, that is also very good. Whenever there is a grayscale shown on the TV, that is also a perfect or near perfect grayscale. So what's the difference? What we did, why it is not good, how we can improve it? The important thing is that when we try to build a better grayscale, the human eyes, they don't feel all the colors equally. So for that purpose, we need to give them some weight or importance. So remember, if you are doing adding, or you are taking the average of three gray colors, so if you do like this, R plus G plus B divided by 3, okay, what does it mean? Okay, I can write it like this also. Just think over it, simple mathematics, plus B over 3. Okay, just separate 3 of them. What does this mean? This means that I take the red color and add the 1 by 3 of this color value, then the green, and then the blue. So what does it mean is that I multiply 0.33 with R and add it to 0.33 with G and 0.33 and B. Okay, so the 3 colors I have got, I use the equal proportion, equal value of these 3 colors to create the brightness average. Scientists found that this is not a good approach, because each color does not have same effect on our brain. Some colors have more effect, some have less. So for this purpose, they did a lot of experiments with the different color ratios, different color values, and they found out these ratios that are more effective. Okay, so they found out that red value we were using 0.33, and practically it is almost 30%, 0.299, which is 30%. Okay, so 30% you can say. And the green value we had 0.33, and practically it has more importance for a grayscale image, and it is as important as almost 59%, almost double. So green is that much important. And finally, blue is the least important color. For the brightness of the blue color is least important for our grayscale images, and it has only the importance of 11%. So it is not plain simple average where each one has same importance. So this was done based on laboratory experiments. So this is what they did, and they used these different ratios, and with these ratios they tried to, and that gave them the best effect. So here they show what they want to say is, when you the result on the left, it is the average, this one, the old technique, and the one on the right one that is shown, this is the weighted one, where they have used the different weights for each color. So practically I don't know how to quantify, but it's not so easy with our eyes to find out the difference. But practically they may have some means to find out the difference, and they say that this grayscale is much better than the simple one. So how we can implement this? Now let's see, go back and we will see over there, and take the same image. Only thing that is changing now is that they want to say that the color values, they are now changed. Okay, the importance is changed. So instead of storing the R, G and B, instead of average I call it weight. Weighted AVG, average. Okay, so it's a special average, not the normal one where each one has different value. So value, how much that value is, the value I can put over here or I can put above. So I will put it in above, and it is 0. So just multiply this 0.299 and multiply by this, and then it is 0.587 multiply by green, and the last one is I think 0.114. So these are the three color values, and this will give you a weighted grayscale, which is what they say is more better than the previous one. You can just add a new variable over here, P3 picture object, and then you can compare the original grayscale and this weighted grayscale. You can try to see which one is better. But personally I don't know how they can evaluate. It's not so easy to evaluate. So this was about the grayscales, what we saw, and it is better when you want to compare the grayscales. It is better if you try to use an image which has more black color content. So then you will be more comfortable with applying the with comparing the two results. So here they have given, on the left it is average, and on the right it is grayscale, and still I don't know how to evaluate it, which one is better. Okay, so this was it about the grayscales. A little bit more about the programming. If you remember, we did it previously, the sunset. Okay, so if you remember, at that time we wrote a code. So let me go back and show you. We saw over there a code for sunset, this one, and there was one for loop, and inside the for loop, so there is a for loop, and inside the for loop there are two colors that are modified, blue and green. Okay, so two colors are modified, blue and green, inside a single for loop. Now you will see a different style. So the same, the behavior is same. it is the same function, but here we will be doing something different. So we use a different sunset generation function. This time the approach is different. Now this is interesting. Look over here. In the first one, if you see reduce blue, there is over here a function, okay, that is only, so look carefully, you can pause the video and observe these code, this whole code. The first one over here, it is reduce blue, so the name is reduce blue, and there is a for loop, and inside the for loop only the blue color is, first of all we use the get blue to get the blue color, and only the blue color is modified using set blue. Okay, so reduce blue, only reducing the blue color. There is another function then we create, which is get reduce green, and if you see, there is no change in the code overall, only one thing changes, the name of the function, get green, set green. All other things are 100% same, there is no other change. So you will think, why there are two functions, why we use two functions if it is almost the same thing? The important thing is that in this code we are trying to make one function for one function for one task, okay. So there is one function and we use it for one task, which what is the task? The first function reduce blue, it is doing only modifying the blue color, it is only reducing the blue color, whereas second function is only modifying or reducing the green color. Okay, so think over it, what's happening. One function for reducing blue only, the other function only reducing green. Okay, so two functions. Why we do this? Because we put one function for one task, that's important. Okay, and we do this so that our code is more understandable. Now we have over here introduced a new function. Okay, the new function over here, what it is, its name is make sunset 2. Why we put a 2? Because if you remember last slide, the name of the function was make sunset. Okay, make sunset. So just to give it a new name, just so that it does not mix with the old one. So make sunset, this one is make sunset 2. And this make sunset 2, it is calling these two functions, reduce blue, and the other one is reduce green. Now you will think, why we are doing all this thing, why we increase the code size, why we did all these extra things. So both these functions, make sunset 2 and the other one make sunset previously, they are doing the same thing. So this one does the same thing as the earlier form, but this one is now more easy to read and understand. Okay, previous code, just to look at that code. Just imagine I give you this code after 1 year. Will it be easy to understand this code if I give you after 1 year and you don't remember everything from your course? And will it be easy for you to recall what is inside this code, what is inside this function? Okay, no, I don't think so. It will be more difficult to understand this code after 1 year as compared to the other code that we see now. This code, so now this one, after a long time, it will be more understandable, because this code over here that you see, it is more based on functions, and it is a modular code. So it is based on modules. Okay, Modular code is a code where you create modules or units for every task. So you see over here, one module will only reduce, or one unit will only reduce blue color, another unit only reduces green color. Okay, so to make a sunset, you can easily understand, to make a sunset is to reduce blue and reduce green. So you are making sunset by calling these two functions, reduce green, reduce blue, and then reduce green. So this type of programming, so now this thing has nothing to do with media computation. This is purely related to programming style. So this thing over here that you see, this is normally called as hierarchical decomposition. Okay, what is hierarchical decomposition? Decompose means to break down. Okay, hierarchical decomposition means that layers of breaking down. So you have a problem. The problem is that you have an image, you want to make sunset effect for that image, and you break down that problem, sunset effect, into two smaller problems. Smaller problem number one is reduce blue, and number two is reduce green. So your bigger problem, make sunset, you reduce it into two smaller problems, and then you make two separate function calls to solve these two smaller problems. So this type of programming approach you see is hierarchical decomposition, where you break the big problem into smaller ones and then use small modules for each part of the problem to solve it. So this version, practically, you see over here, there is more code in this compared to the last style of programming. This programming here has more code. This version will be definitely inefficient, not so good. Programming efficiency will not be good. But remember, the important point of this whole slide over here is that programs, they are written for people, not for computers. Even this program is big or small, computer will run it, and maybe it will run very, very fast. But the more important thing is that the program that you write, it should be understandable to you when you look at this program after 1 year. Okay, remember the general theory about this thing, the general rule is that a code that is written by you yourself, the code that is written by you will be something totally new to you if you look at it after 6 months. So with the gap of 6 months, code even written by you will be totally new to you. So that's why it is very, very important when you are writing a program or a code, it is very important that your code should be based on more and more modules. It should be modular, more and more functions, and it should be based on hierarchical decomposition. The big problem is broken down into smaller problems, and then those smaller problems are separately solved using separate functions or modules. I hope this one is clear. Very, very important point. Make sure you understand it. For your project also, I check this thing, and this thing has got important marks that all of the students, they make their project and they try to use a separate function or a module for each part of the project. Okay, so if everything is mixed together, that's a very bad, that will make marks less. So always when you try to solve something, there should be a function for each part of the problem. So I hope this is clear. We finish the lecture here. Next time we will come with more of the details.